Hello, my dear students. Welcome back to the lecture. So from here, we'll try to take up the questions and we'll try to find how those questions can be answered. So we'll begin with that. So whenever we go for the interview, we are going to take up some basic questions right now. For someone who knows, it's well and good. For someone who doesn't know, this is how we can start it. So the first question is that what is cement, right? So just take 2 or 3 seconds of your time and try to think what you can write. Or if they ask you suddenly what is cement, try to think what answer you can give. Then we'll say what answer you have to give as a from a technical point of view. So cement is a binder which binds any two materials, right? So this is a very basic answer what we can give. Or even you can start your answer by telling if I ask you for the two piece of paper. So what we are supposed to do, if I ask you to glue any two piece of paper, then you are going to ask me for the glue, isn't it? In the same way, in a civil engineering language, whenever we want to bind any materials, let us say I have a coarse aggregate, I have a sand, and I want to prepare a concrete, then I need some binder. So I can take cement as a binder. So you can try to answer even in this way. You don't have to answer from a textbook point of view. It all depends how you have understood the concept, right? So if everyone answers that cement is a binder, cement is a binder, if you try to add the answers, that's not going to help you. So try to answer in your own way, right? So you can say that cement is a binder which binds any two materials. And in a civil engineering language, cement will be used so that we can bind any material. And especially in case of concrete, cement is that particular material which actually helps in the binding property. This can be a better answer. Yeah. Now coming to a bit history of that, even you can try to add this part also. So cement is an artificial hydraulic lime which can set in damp conditions and in water. So actually, even before the invention of the cement, we were making use of lime. If you had seen a lot of ancient structures and all, we used to make use of lime. We even constructed the dams with the help of jaggery. If you know that jaggery and banana are very good. Yeah, banana is also very good. Recently in my place also, there's a temple which was around 600 to 700 years old temple. So what they have done is with the help of banana, because when you crush the banana, a lot of heat is liberated from that. So with that, you can even get the binding properties. And also lime is also very good binding agent, because if you go to the even the jaggery is also a very good thing. If you visit the KRS dam, let me write it here, because few things we need to understand. So if you visit KRS is Krishna Raja's Sagar dam, which is in Mysore, okay, which was constructed by Sir M. Vishwesharaya. On that day, we celebrate Engineers Day in India, right? So that particular dam is constructed with the help of jaggery, right? So that also was a binder. And cement, of course, and of course, the lime, we try to use it in a lot of construction. But the problem with the lime is that it cannot set quickly. Got it? It cannot set quickly, and it will take long time to set. The second is that the lime requires an open environment. Like if I take one brick, and over that if I put a lime, and then if I keep the second brick, then what has happened, this lime will take very long time to get set, because it is not, first thing is that it is a slow set. Second thing is that it is not getting enough environment. There's no flow of air in the lime, so the setting won't happen. So this were the two problem with the lime. And then what we started to do, then we started to invent the cement, right? So one thing you need to understand, so you can take it as a kind of assignment. Try to say what are the ingredients present in the lime, that means the raw materials, and also try to say what is the raw materials present in the cement. Both the raw materials in the lime and the cement are same. Only the thing is, what we did is, instead of taking a pure lime, we started to add a lot of impurities into that. So when we started to add a lot of impurities into that, then what has happened, that lime itself got converted into cement, right? So that is why I've written here, cement is an artificial hydraulic lime. It is actually a pure lime. If I take only lime, it is a pure lime. But if I try to add a lot of impurities into that, then it becomes a cement. So that is why cement is an artificial hydraulic lime, which can set in the damp conditions and in water. What was happening with the lime? So lime was not able to get set in the damp condition and also in the water. But whereas cement, we can try to add a lot of impurities and all. And that is how the invention of cement came. Got it? The first cement was manufactured in the 18th century by Joseph Aspidin and M. Wickett, called as ordinary Portland cement. So India is the second largest manufacturer of the cement in the world after the China. So, right. So now in a very simple way, you can try to answer this, but these are a bit history what I have told you, so that you can try to add this to the answer also, so that you can give a very better answer, right? Yeah. So we have understood the first question. Now we'll go to the second part. Now they may ask you what are the different types of cement. So obviously, if you are studied engineering, you know what are the different types of cement. So you just have to remember them. So we can start with like ordinary Portland cement. Then we have a blast furnace slag cement. Then we have rapid hardening cement. Then we have extra rapid hardening cement. Then we have sulfate resisting cement. Then we have high alumina cement, air entering cement, white cement, and so on. So there are more than 15 to 16 different types of cement. Now you don't have to remember everything. Even if you remember 4 to 5 cement, it is good. Ordinary Portland cement, we can remember. We can even remember a quick setting cement. We can remember low heat cement. We can remember air entering cement and white cement and high alumina cement. This much are enough. Now, if the interviewer goes one step ahead and asks you, okay, you have mentioned about high alumina cement. Can you explain me what is the difference between an ordinary Portland cement and a high alumina cement? So in that case, you need to be a bit, what you call, we have to know the basics of that. So what I'm going to do is, I'll not explain it here. So if you have taken my concrete technology course, I've explained all those things here there. So what I'm going to do is, I'll show you the PPT for that quickly. So this was the thing, what was covered in my concrete technology course. Otherwise, I'll add 1 or 2 lectures of that particular course at the end of this lecture, so that you can take this as a revision. If you want, you can buy this, else you can, I'll be adding the same lectures here, right? So for the rapid hardening cement, I have done an explanation something like this. Okay. Then the application part is where rapid gain of strength is required, like in the pavement construction, because pavement, I cannot keep it, closed for a very long period of time. I want to construct the pavement and quickly I want to allow the traffic to move that. In that case, I need to make use of a cement, which is going to give me a quick, strength. So rapid hardening cement comes into play there. Then in the emergency repair works, in the precast construction, in case of speedy construction where early removal of the formwork is necessary, you can make use of rapid hardening cement. Then next is a extra rapid hardening cement. It's again a rapid hardening cement. Along with that, we try to add an accelerator, and that accelerator is calcium chloride, right? Again, all these are the explanation I have given there. Now again, after that, you can even explain about the quick setting cement. Of course, by the they may ask you one question: what is the difference between an ordinary Portland cement and a quick setting cement? So the very simple answer what you can give is in the ordinary Portland cement, we try to add gypsum. So when we add gypsum, what will happen? The setting of a cement will not happen quickly, right? But when I say quick setting cement, that gypsum itself was stopping the setting, isn't it? The gypsum itself was actually, let me tell you the history behind that. So when we try to add a gypsum, into the cement, what is going to happen? It will try to coat a layer around the cement particles. The moment you add water, so water will not directly react with the cement particle, but the water has to first fight with the gypsum. So once all the gypsum layers has been removed, then the water will try to react with the cement, and only then the hydration is going to happen. So the time taken by the water to fight with the gypsum, that itself will help me in delaying the setting of the cement. Delaying in the hydration. So if I want to make it quick setting, what I'm supposed to do, this gypsum itself is stopping me. So let me take out all the gypsum out. Then whatever cement is left out, that is called as quick setting cement. So you can see it here. Quick setting cement is a gypsum-free cement manufactured using less amount of gypsum and more alumina content. Then how much quick it is? That is initial setting time will be 5 minutes. In ordinary Portland cement, the initial setting time is 30 minutes. But whereas in quick setting cement, the initial setting time itself is 5 minutes, right? And final setting time can be around 1 hour or 30 minutes in this way. So again, they may ask you, what is the strength gain, whether in the quick setting cement and in ordinary Portland cement, what is the strength gain? Then you can tell the strength gain will be same, since we are not changing the C3S proportion. We know that the strength gain will happen because of the tricalcium silicate. We'll try to say what is C3S in the next lecture, but try to understand a bit history about that. So a tricalcium silicate will react with the water, and we are going to get that CSH gel. That CSH gel itself is called as tobermanite gel. That itself will act as a binder to the cement, right? We call cement binder because of this CSH gel. Got it? So we are not changing this proportion. So the strength gain is going to remain same in the quick setting cement and also in the ordinary Portland cement. Only the thing is, it is going to quickly react with the water. Hence we call this as a quick setting cement. Application is underwater concreting, seepage repair works. Got it? Right? All these things has been explained in a more better way. Then we have a low heat cement, especially in case of dam construction. We try to make use of this low heat cement because dam construction is a massive construction. Huge amount of concrete is required. So the moment you add water, a lot of heat of hydration will happen. And if you are doing a mass concreting, due to heat of hydration, the cracks are going to form. So I don't want my dam to get a crack and all, right? Because it's a water retaining structure. So in that case, what we are going to do, we are going to increase the C2S contents, that is a dicalcium silicate content, and we are going to decrease the tricalcium silicate content. So you can see it here. This cement is obtained by reducing the proportion of tricalcium aluminate and C3S, because this itself are responsible for the early setting of the cement, and increasing the proportion of the dicalcium silicate. What? Got it? Other than that, there are their own advantages and all. So you can go through this lecture and understand, right? Other than that, there are many other cement, like we have Portland pozzolana cement, then we have Portland slag cement, then I've explained about the colored cement, and of course the hydrophobic cement is also a very good cement. You can give an explanation to that. In hydrophobic cement, what will happen, let us say you want to do the transportation, okay, of your cement. Let us say right now I'm in Bangalore, and I want a cement bag to be brought from Assam. So from there it will come through, let us say, a truck. So in the middle, if it starts to rain, even though I cover it, there is a chances of my cement reacting with the water, and by the time it reaches to my place, all the cement will get set. I don't want that to happen. So what I do, I try to put a layer around the cement particles, which we call that as a water repellent. That means you can see whatever is a ordinary Portland cement, you add a water repellent chemicals to that, like stearic acid and oleic acid. And then if water comes and starts to react, this water repellent chemicals will stop the hydration of that. So in this way, we can make our cement hydrophobic cement. Now you may ask me one question. So that is okay. Let us say all the cement from Assam has reached Bangalore. And now if you want to mix it, the moment you add water, then also it's not going to mix. Then how can I make use of this cement? So when we try to mix this hydrophobic cement, one thing we need to understand, we have to mix it very rapidly. The moment you start to mix it very rapidly, whatever the coating we have, that is this water repellent chemicals like stearic acid and oleic acid, it will be broken down, and obviously this water will try to react with the cement particles, and that is how the cement is going to get set. So this itself, that is water repellent chemicals, are going to stop that hydration process. So that is why we call this as hydrophobic. Okay, this much is understood. Yeah, other than that, all these things I've explained, high alumina cement and all. Try to understand 2 or 3 cements in more depth, like hydrophobic cement is a good explanation you can do. Then you can even explain about ordinary Portland cement and quick setting cement. So 3 or 4 is enough. You don't have to remember everything, then you're going to forget everything. So even if you remember 2, but try to explain that in a more better way, right? Yeah. So we are done with 2 questions, and I hope you are in a position to understand that. Yeah. Now they may ask you what are the different grades of cement, which is a very basic question. You can tell we have a 33 grade cement, we have a 43 grade cement, and we have a 53 grade cement. So whenever they ask a question, the best practice what you can adopt is you can ask them for a pen and a paper so that you can write it. Of course, for this question, the written explanation is not required. Maybe when they ask you some other question, a best explanation would be write it and you can explain it, right? Yeah. So 33 is understood, 43 and 53. Then you can add one more point to that. Right now in the market, 33 grade cement is not available. Whatever is available in the construction is a 43 and a 53 grade. And also for most of the construction, we either go with a 53 grade of cement. This explanation, if you want, you can add it to that explanation. Else you can just say 33, 43 and 53. Because sometimes when you try to explain more, you may get a counter question. So it's always better just answer whatever they ask him. So we'll restrict our discussion to 33, 43 and 53, right? They may ask you one more question. Then what do you mean by 33, 43 and 53, which you already know, right? What is this 33, 43 and 53? They are the compressive strength of the cement. When I say 53 grade of cement, at the end of 28 days, when I do the cube testing, I mean, when I do the testing on that, I should get a strength of greater than 53 Newton per mm square. Only then I can say it is a 53 grade cement. He may even ask you one more question. Can you explain the procedure for that? Obviously, it's a very simple. So we need to take a cement and sand in the ratio of 1:3 with some percentage of water and fill in the mold of 70.7 into 70.7 into 70.7 mm. So this is very important. When we do the cube testing, we take 150 by 150 by 150. But for the cement testing, we try to take 70.7 into 70.7 into 70.7. And we do the casting of that. So you can see a cube. So this particular cube, what you have. So even if you want, you can draw it and show if it's required. Yes, you can just explain it, no issues. So this is 7.07, this is 7.07, and this is also 7.07. Okay, so in this way you're going to take a sample of 3. We'll never take a sample of 1. You can take a sample of 3, and then what you're supposed to do, yeah, once you prepare that, you will demold it, you'll do it curing for 28 days, and when you do the compressive testing on that, then you should get a grade. The average of these 3 has to be greater than whatever you're taken. If you have taken a 43, the average of this should be greater than 43. Only then I can say it is a 33, 43, and 53 grade of cement, right? Yeah. So I think this much explanation is enough. So whenever you try to explain it, other than that, they may ask you one more question. They may ask you, when you're doing a test on the cement, why is that you've taken sand? Why you can't do directly on the cement? So the one answer for this is that if you take only cement, what will happen after some time, the cracks are going to appear. So that is why what we do, we don't want the cracks to appear. Even if the crack appear, of course, even before the testing itself, there's a crack, I cannot do the testing on that. So that is why, in order to not have that crack, since we want to find the compressive strength of the cement, we are trying to add a sand, and that is a practice what we adopt. So this is the best answer what you can tell, but you yourself don't have to tell all these things. Okay, if they ask, you have to answer it, right? But main important thing what they expect is to tell the dimension of this 70.7 into 70.7 into 70.7, and 28 days is a date that you have to tell. And they may even counter you one more question, why is that you're doing at the end of 28 days? We know that, but anyhow, in the future lectures also we'll be trying to take up this, because we know that 100% of the strength will be achieved at the end of 28 days. So that is why we try to do it on the 28 days. They may ask you whether you can do it on 7 days. Of course, we can do it on 7 days also. We can do it for even 14 days. We can do it on 28 days at any cost you have to do. Then they may ask you one more question. Why is that you're doing it on the 7 days? So 7-day testing is done. So get an idea whether at the end of 28 days, we are going to get that particular strength or not. That means we have certain thumb rules. When I come to the cube testing, I'll explain you that. So if I'm supposed to get a 43 grade of strength, so at least a 2/3 of the strength should be achieved at the end of 7 days. That's something, a kind of a thumb rule, when I don't remember, but when I come to the cube, I'll be explaining that. So if I get that 2/3 of the strength at the end of 7 days, then I can come to a conclusion. Okay, this particular sample, whatever I've done, obviously it's going to get a strength more than that at the end of 28 days, and you can proceed with that. Got it? So that is how it has to be understood. They may ask you one more question. So I'm trying to ask a lot of questions, whichever comes to my mind, we can note it down, right? So they may ask you why you have taken 3 samples, because that is how the thing is written in the code book, that you have to take a minimum of 3 samples. And you can give one more solid reason to this, because the cement and all, we cannot predict the strength, because since we do manufacture, even though we do a lot of quality test and all, but still we cannot predict the nature of that. So instead of taking one for our better, what you call, to get a strength in a better way, and also not to have any problem, we try to do a casting of 3 cubes. If they ask you, can you do it for 4? You can even do it for 4. You can even take 5 samples. You can even take 6 samples, no problem. But minimum you have to take 3 samples. That is what is written in the code book. That is why we go with the specimen of 3. Got it? Yeah. Yeah. So this is a very general question what they can ask. They may ask you list the different types of companies which can which manufactures the cement. Whichever comes to your mind, you can tell. I've taken a lot of company here. You can go with you can tell Ultratech, JK, ACC Cement, JSW, Birla Cements and all. Got it? Yeah, but try to at least name a good company. See, there are some interviews who may even tell you, I don't want to hear the name of Ultratech. I don't want to hear the name of ACC. I don't want to hear the name of JSW. I don't want to hear the name of let us say Ramco. You tell me other cement. So in that case, you may be in a trouble, because these are the 4 major brands, and everyone knows that, right? Sometimes you should go out of the box. I mean, out of the box thinking should come. So instead of remembering these 4, try to remember some other cement, so that you can win that particular situation. So you can remember of Bharati Cement, which very few of us know that. You can even remember of let us say Penna Cement. You can, okay, 2 other. Then you can even remember of Malabar Cement, and then of course you can remember there is one more, Ramco Cement, right? So these are, anyhow, these four, if you remember, Ultratech, JSW, and ACC, anyhow, it is going to come. Even if I ask you at 12 o'clock in the midnight, you're going to remember that. So try to remember the other four so that you are on the better side. Yeah. So how long, a last question for this particular session, how long a cement can be stored without consuming in the, without consuming? Yeah. So you can say that usually it will be written on the bag of a cement that this cement is best before 3 months. So 3 months from the date of manufacturing, you can try to use that particular cement bag. Now, what will happen if you try to utilize that particular cement beyond the 3 months? Let us say today you brought, and after 3 months from today, you're going to use it. So what is going to happen? See, the first thing is that even after 3 months, it's a cement only, provided it should not come in contact with the water so that there is no hydration has happened. The one thing you need to remember. After 3 months also, you can do the testing on the cement. You can do the initial setting time and you can do the final setting test. And if the results are within the specified limit, then you can go with that. No issues with that. So it is telling that 3 months from the date of manufacturing, it is never telling not to use that. You can use it within 3 months. Even after 3 months, if you want to use it, you can do the test. So it's written here, age of a cement and percentage of the cement strength reduction. So up to the 3 months, almost 20 to 30% of the strength reduction will happen. If you're storing your cement without use for 6 months, 30 to 40% of a reduction will happen. And if you're storing your cement for 1 year, then almost 50% of the cement strength is going to come down. Okay, this is based on the research and all. Now that may not be the same case with you. So the best answer what you can do is up to 3 months we can use the cement. Even after 3 months, if you want to use the cement, there may be a strength reduction, but we can do the test on that. We can try to do the initial and final setting time on the cement. And if we get the answer within the limit, we are good enough to go with the cement. Now we can give one good example. Sir, during the time of COVID-19, a lot of everything had come to a shutdown, right? Almost there is a 1 year of lockdown. So during that time, there's no construction happening, isn't it? So whatever cement bag we had manufactured, so we actually used that cement bag later. But only the thing is, we did a test on all that thing, and that is how it has to be done, right? So one is your textbook answer can be this one. Practical answer, you can try to give a situation also, like during the time of COVID, these things happened. You can try to do a kind of a research. I have not done it. I'm giving you an idea. Try to put it on the Google. Try to see what happened to the construction industry in the COVID-19, or try to ask a question, what happened to the cement bags that were stored during the time of lockdown? So you may get good answers from there. You try to note it down and you can present the same thing in the interview, right? Yeah. So these are the things which will be written on the cement bag. We'll try to take up a bit later, but still you can get an idea. If you see any cement bag, what is going to happen? They are going to mention the grade, whether it is 33, 43 or 53. What kind of cement it is, whether it is OPC cement, whether it is a PPC cement also. And then of course a brand name will be there, Ultratech, Coromandel, whatever. What is the price of that particular cement bag, MRP of the bag, manufacturer's name, who is the manufacturer of that, batch unit number, ISI mark will be there, IS code. This is also important. We'll take up the IS code a bit later. And use guide, that is use no hooks. You cannot use the hook since there's a fine particle in that. So those things will be written. So just have an idea regarding this. They may even ask you a question, what may be written on the name on the cement bag, right? So I hope, yeah, I hope you enjoyed the lecture up to here. You got a certain idea regarding what has to be told and all. So just put a picture here just to boost your confidence. Okay, that is congratulations, you have been selected. So you have to take up this course thinking that you are selected in the interview, right? But don't get carried away with that, but try to understand what has to be told in the interview and try to note down, make a very good notes out of it, so that and you can try to revise it, right? So we'll see you back in the next lecture. Thank you.